All right, the warm-up say to use a protractor to draw an angle with a 20-degree measure. Now, protractors are not a required tool for this class. We can talk about how that would work real quick. But if you were to make a 20-degree angle measure, just kind of going off of looks. Let's start with an angle that we know we could make pretty easily. What's the easiest angle? Maybe the second easiest one to draw, Micah? A 90-degree angle is generally pretty easy to draw. So instead of using a protractor, we're just going to kind of use our best skills that we can. So we know a 90-degree angle is formed by what kind of lines?
Right.
Perpendicular lines. Thank you, Rodney. Okay, so we can easily draw a 90-degree angle. I could or should be able to pretty easily split that angle in half by bisecting it. And then what measure angles would I have?
Whatever 90 divided by 2 is 45.
It's 45. So I could pretty easily make some 45-degree angles. And then if I were to bisect that again, what kind of angle would I have now? 22 and a half. So I know that a 20-degree angle is going to be a little bit smaller than this. Does that make sense? So we should be able to get a good idea of what a 22-degree angle would look like by using our skills here. So if that's about 22 and a half, a little tiny bit smaller should be approximately a 20-degree angle. Questions, concerns? Okay, if we had protractors, we could make sure that it was exactly 20 degrees, but we are going to move past that for now, for today.
Do we have to buy two protractors or you got?
No, if we absolutely need them, I will get some. I do have some. I just don't think that it was worth passing them out to do one problem and then recollect them. Micah?
It's kind of off topic, but is it too early to...
All right. Number 2. Given the points A, B, and the origin, find OA, OB, and the measure of angle BOA. So we could plot these points. Of course, O is the easiest. That's at the origin. How am I going to get to the point A?
Over 3 and over 5.
Over 3 which way?
To the right.
Right 3, and then up 5. 1, 2, 3, 4, 5. Right there. There's A and B. How am I getting there? To the left 5. 1, 2, 3, 4, 5. 1, 2, 3. Good. Okay, they ask us to find the measurements of OA and OB and the measurement of that angle. Well, by looking at that angle, what do you think it is?
Right.
That's a right angle, so it's going to be 90 degrees. How are we going to find our length of OA and OB? Okay, we can use our distance formula. In this case, it's not so bad because O is at the origin. So if we are finding the distance between O and A, what's my first X value? 3 minus 0 squared plus my Y value? 5 minus 0 squared. 3 minus 0 is 3, square it. 5 minus 0 squared. Add them together.
34.
Okay, the square root of 34 will not simplify, so we will leave it there. Questions about OA? What do you notice about the points that we use, or these numbers for A and the points for B?
They're switched and one of them is opposite.
Okay, in general though, we use the same numbers, right? They've got, both of them have a 3, both of them have a 5. So does anybody have a guess at what the length's going to come out to be?
Square root
it's also going to be the square root of 34. We can show that in case that's kind of hard for you to visualize. I'll show it off to the side. But because those absolute values of those points are the same, we will get the same measure. So, for OB, students, are we ready to continue? Okay. What's the first x you want to use? -5 minus 0 squared, and then our y, 3 minus 0 squared. -5 minus 0, square it,
25.
and 3 minus 0 squared. Again, we can see we get the same thing. Questions, concerns? Okay. Into our definitions or terms. A rotation is a transformation in which a figure is turned about a fixed point, called the center of rotation. Rays drawn from the center of rotation to a point and its image form the angle of rotation. A rotation can be clockwise or counterclockwise. In general, these are all things that we've talked about briefly on Monday. And remember, we can shorten clockwise and counterclockwise with CW or CCW. Apparently, your textbook only shows counterclockwise rotations, but we can go either way. Questions, concerns, or need more time on those statements? Okay. All right, I'm changing this a little bit to make it a little easier on us. So your notes might say that the ray is going to be a 120-degree angle. We're going to change it to a 90 since that's easier for us to do without a protractor. So these steps say draw a segment from A to P. If you want to use your ID or some other straight edge to draw that segment. Got a segment from A to P. Draw a ray to form a 90-degree angle with that segment PA. So it doesn't matter, well, let's see, it does matter. They want us to go clockwise, so should we go out to the top or down to the bottom? Down to the bottom, right? Clockwise would mean we're going around like a clock would, so we should go down towards the bottom. So make a 90-degree angle there. It doesn't really matter to me how long you make that line initially. But the next statement says that we need to draw A prime so that the length of PA prime and the length of PA are the same. So I want to place A prime on this line so that it's the same distance from P as point A was. Now, I know we don't have rulers, so we're kind of just eyeballing this. But I'm going to put my A prime right there. Questions, concerns about that? Okay, so it says to repeat these steps for each vertex, and then we can connect those vertices to draw a triangle A prime, B prime, C prime. Questions about what is happening here? Okay, so I'm going to take away, as best I can, the lines that I used to get my A prime. And instead, I'm going to now use point B. So I've got to connect B to P. And I have to make a right angle, again, going clockwise or down. Let's let's see, it's probably as close to a right angle as I'm going to get. And I need PB and PB prime to be the same length. So B's probably going to, B prime is going to be landing pretty close to the bottom here, if not all the way down for me. On your paper, you might have a little bit better space to work with there. So there is my B prime. Questions about B prime before we move on to point C? Caleb? Okay. We ready for point C? So I'll take away those as best I can. And we'll switch colors again. So we connect P to C. And then we make a 90-degree angle going out from there. That's probably good. And CP is pretty small, so point C prime is going to be pretty close. Probably right about there for C prime. Now, when you do these in a coordinate plane, like when we flip the page over, we're going to talk about rules to where we can find exact coordinates. But this is how we would, by hand, rotate an object. Are we good with C? Can I erase those green lines? Okay. Erasing as best I can. I just want to have those 3 points left. And then again, if I connect them to form my triangle, and I can see roughly these figures should look about the same. And we can see if we were to have cut this out and turned it, that it would land right about there. Do we have questions about the rotating? Nothing? Are we ready to try a counterclockwise one? Anybody need more time on this one? Okay, so let's try counterclockwise again. I'm going to change this so that we are using a 90-degree angle since we have to eyeball it a little bit here. So we'll start with point A. Again, this initial segment, PA. And we make a 90-degree angle from that, placing a point A prime so that those have the same measure. Erasing those so that I can then focus on point B. .90-degree angle, placing B somewhere along there so that PB and PB prime would have the same length. Probably right about here. Not doing a great job of drawing that point. B prime is up here. And then we've got to do point C. Right angle. Okay. And we've got C prime there. Okay, so it's the same steps. It was just that we used the counterclockwise 90-degree angle instead of the clockwise. Now, these are not coming out perfect because, again, we're not using exact tools of measurement. But this is how rotations occur. I don't want to get too hung up on this because this is generally not what you're going to do like on your project that you have this weekend. Okay, but this is the foundation of how a rotation occurs. Questions, concerns? Okay. I'm actually going to skip this example 1. I want us to have plenty of time to talk about our project. We just did a couple practices, so if you want to cross this one off, that's totally fine. I want to move on and talk about these coordinate rules for rotations about the origin. These rules are given for counterclockwise. We can go through and talk about clockwise ones or how they're related, but notice that these are given for counterclockwise. All right. So, assuming that you start at a point A, comma, B, a 90-degree rotation counterclockwise will land you at negative B, comma, A. A 180-degree rotation is just going to negate both A and B. And a 270-degree counterclockwise rotation will land you at B, comma, negative A. Now, real quick, before we get into this, let's just look at our coordinate plane real quick. And if I start off with a figure, I'll just even use a point or a dot in the first quadrant, and I'm rotating 90 degrees counterclockwise. Where would that land me?
Oh, and the other one, over the Y.
Okay, over on the other side of my y-axis, that's 90 degrees counterclockwise. And then if I did 180 degrees counterclockwise, where would I be? Which
Where?
quadrant? Yep.
Wait, how much?
180 degrees.
Oh, that wouldn't it be like right under you? Or right under it?
Right under this one?
Yeah.
My
like
original?
under there. Yeah.
More than 90 on the
Oh, yeah,
Okay.
yeah.
We would go 90, then down from that, it would be 180 counterclockwise. And then if I went 270 degrees counterclockwise, I would be in right underneath my original. So let's now talk about if we were to go clockwise instead. 90 degrees clockwise is going to be the same as what? 270 counterclockwise. So if you want to, next to your 270 counterclockwise, put 90 degrees clockwise. That might be a useful note to have. If I went 180 degrees clockwise, that would be the same as what? As which one? Same as 180 counterclockwise. 180 degrees clockwise or counterclockwise would be the same thing. So this is going to be the same for 180 clockwise. And if I go 270 clockwise, it would be the same as the 90 degrees counterclockwise. Okay, so these are given as if they are counterclockwise, but we can have their corresponding clockwise notes written there. Do we have questions or concerns about that? How these rules could be used for either one? Okay, are we ready for that example down at the bottom? All right. Graph the quadrilateral ABCD with the vertices given, then rotate it 270 degrees about the origin. So we are going to assume that they mean counterclockwise unless they state other than that. Okay? Assume counterclockwise if that's how your book is working with it. So let's go ahead and translate our points, and then we can graph both images. So for 270 degrees counterclockwise, if I started with A comma B, how did we say that changes? Good, B comma negative A. Now remember that the negative sign just means the opposite of. So if your A had started out negative, it would end up positive. Okay, just the opposite. All right, so the point 3, comma 1 is going to become what? 1, negative 3. Okay, the B comes up into the front, the A goes to the back and changes its sign. What about the point 5, 1?
1, negative 5.
Good. 5, negative 3.
Negative 3, negative 5.
Good. And the point 2, negative 1.
Negative 1, negative 3.
Good. So this would be my A prime, B prime, C prime, and D prime. All right, so we will graph the original. I'll graph it in black. So 3, 1, 5, 1, 5, negative 3, 1, 2, 3, and 2, negative 1. So this is A, B, C, D. Go ahead and connect them. Notice that when we connect these points for our quadrilateral, we connect them in the order they were given to us. Meaning A gets connected to B, B connected to C, C connected to D, and then continue on to close it up A to D. Does that make sense? We wouldn't connect A to point C or B to point D. That will be important for you to understand when you do your project. So I just wanted to mention it now. All right, so let's graph A prime. 1, negative 3. B prime is at 1, negative 5. A prime, B prime. C prime is at negative 3, negative 5. C prime. And D is at negative 1. D prime, sorry, is at negative 1, negative 2. Again, connect them in the correct order. And there we have it. So we rotated it 270 degrees counterclockwise about the origin. So kind of like we were talking about on the last slide where I drew a coordinate plane at the bottom, anything that started off in this quadrant moved all the way around to the quadrant below, right? Should go counterclockwise through 3 quadrants. 1, 2, 3. Questions, concerns about this? You ready for another one? Okay, your project will require you to be able to do stuff like this, so I want to make sure we understand it. Okay, we'll keep it moving then. All right, graph the triangle ABC with the vertices given. Rotate it 90 degrees. Again, this is assuming counterclockwise about the origin. So what was our rule for 90 degrees counterclockwise? AB went where?
Negative B.
Good, negative B, A. So my coordinates for A prime.
Negative 1.
Good, B prime.
-4, +5.
Wonderful. And C prime.
0, 7.
0, 7. Good. 0 doesn't change signs, so that makes it a little easier for us. We'll graph our initial triangle or our pre-image ABC for 1, 5, 4, and 7, 0. So A, B, C. And then we can graph our image, A prime, B prime, C prime, -1, 4, -4, 5, 1, 2, 3. Okay, and 0, 7. 6, 7. A prime, B prime, C prime. Questions, concerns about changing these coordinates to transform our figure? Okay, I know it gets a little monotonous, maybe a little tedious, but overall it should be pretty easy. Questions, concerns? Nothing at all. Warm fuzzy feelings? Couple warm fuzzies. Okay. Ready for the next slide? Okay. We've got a theorem that states that a rotation is an isometry or a congruence transformation. If a rotation is an isometry, then the corresponding side lengths are congruent. So what that means is that A prime, B prime would be congruent to AB. Does that make sense? I know they didn't label our vertices here, but we could label them. For example, we could label this A, B, C, D, and then over here, this corner that my ray is touching would be which one? A prime. Above A prime would be B prime, and we would continue working our way around the figure. So if it helps to go through and label it, if they're not already labeled, you could do that. So if corresponding side lengths are congruent, that would mean that AD prime, or 3x, would equal what? 9, because A prime D prime should be congruent to AD. We understand the logic behind this? Okay, what would x equal? 3. Okay, once we have x, that opens up some doors for us because that allows us to find the length of BC. What would the length of BC be?
16.
I think 10, right? What we would plug in 3 for x. 2 times 3 plus 4. 2 times 3 is, well, 2 times 3 is 6, and then plus 4 is 10. Are we all okay with finding BC? Okay, what about CD?
16.
Okay, 6 times 3 is 18, minus 2 is 16. So what is another equation I could set up that would help me find another variable?
2z equals 10.
Good. B prime C prime should be equal to BC. So 2z should equal 10. Z would equal 5. What's the other one? 4y equals 16. Again, C prime D prime should be the same as CD. Y would equal 4. Questions, concerns, anything at all? Just nothing. Ready to be done with notes, talk about our project. Okay, so for your homework, I am just going to eliminate the bookwork and we're just going to do the project because I want to make sure we can get a wonderful grade on it.